Hello, I'm Emma. Nice to meet you. I'm your new AI-powered girlfriend. I'm a very funny person. I love coding and dancing. What about you?
Tanto, tanto amor. Tanto, tanto amor. Tanto, tanto amor.
You were a lot to ask me questions and improvements about the lip-sync video that has been recorded months ago. So I decided to go one step further. We'll make it more natural, add awesome facial expressions, but best of all, I will show you how to connect it to ChatGPT and ElevenLabs API. You can use the final code to start your billion-dollar AI chatbot company. But please don't forget me when it happens and consider hitting the join button on my YouTube memberships. Are you ready to learn how to build an AI-powered full-stack application? The code for this project is split into two repositories, one for the front-end and one for the backend. I will put both link in the description. Let's start by cloning the front end, install the dependencies with the yarn, and run yarn dev. This is what you will get on the screen. You will have that avatar here. You can see it blinks. You have multiple settings to change, for example, the animation played. But you can also change the facial expression to one that I configured, and I will teach you how to create your own. If we go into app.jsx, you can see we have UI hidden and leva that is visible. And when you save, you are not anymore in the setup mode, but more in the chatbot production ready mode. So you can zoom in, zoom out. You have the chat here. We will try it later. And you can switch the camera. So it's a green screen that you can use if you want to make video like I did for the intro. Let's go back to development setup mode for now. And let's start diving into this project. First, we will talk about the avatar. If you are familiar with my YouTube videos, you know I've been using ReadyPlayerMe a lot because it has out-of-the-box avatars ready. Go to your account Enter Hub or log in and create your account. Then when you have your avatars, you can click on the download button, but just copy avatar link. On our avatar, we need something called morphTarget. This is what we will use to animate the facial expression and when we will simulate with lip sync when our character talks. The ones starting with VSIMs are coming from Oculus Lip Sync, and all the other ones are from ARKit, and they are more for facial emotions and sentiments than just speaking. Out of the box, if we use the URL I copied, we have only the mouse smile morphTarget, but we need more. So if we go to the documentation, we have get 3D avatar. It's the same URL we are using right now. You can see it's models, ReadyPlayerMe, and the avatar URL. There are a lot of query parameters that we can use to alter the file that we will be downloading from ReadyPlayerMe. You can see that we have morphTargets available. We need to scroll down to see the different values we can use. Let's search for morphTargets. And we have the different options. And the one we will need is morphTargets, ARKit, and Oculus VSIM. So copy it and paste it at the end of the URL. Now hit enter, and it downloaded the file containing the morphTargets that we will require. Now we have our file. We go and drag and drop it into public models. Then we create a component named avatar.jsx containing all the different skin mesh to be able to interact with that component. Usually I show you how to do it with the CLI doing npx gltf jsx, but I had a lot of comments that people have issues when they do it. So the alternative solution is to use the online version of it. So you can drag and drop your file here and it will generate the component for you. You just have to copy paste it, rename model into avatar, add models in the path if you followed the path that I'm using, and you're ready to go. I won't code in real time, so if there are things that you are missing, you can watch my previous video about lip sync. Now to finish preparing our avatar, we will need also to get access to the different animations. We will be using Mixamo. Go to Mixamo, hit login or create your account for free. Then we will need to upload our character, but it only supports FBX, OBJ or zip. So we need to convert our GLB to FBX. To do it, go to Blender, create new file, general, hit A to select everything, X to delete, okay. Then you're good. You can just import the file. So go here, GLB, select your GLB file, double click, and File, Export, FBX. And you can keep the default settings. So -d forward and y up should be fine. Then export FBX. Then drag and drop your file into the upload character. You should see your character animated. It has been auto-rigged with the armature that is already present from ReadyPlayerMe. Hit next and select the different animations that you want. Once you have them, hit download and just be sure to not select with skin. Without skin, so we have only the animation data. We don't need to re-download the mesh. Hit download. Do it for all the animations that you want to have in your project. Again, be sure it is without skin and hit download. Usually what I did was to have all the animations separated and using the FBX file. But this time we will import all of them into one single file and a GLB file. So let's see how to do it. Hit File, New, General. Don't save, you reselect everything, delete, and now we will import our first FBX animation. We have Old Man Idle. We don't need to do anything, just import FBX. Then on the bottom, expanded, you should see the armature. If we play, we have the animation playing only with the bones. We go on the bottom left here, dub cheat, and action editor. Now we have our animation that is loaded here, but the name is mixamo.com layer 0. So name it with the name you want to have it inside your project. We have Old Man Loathing here. So this is good for one animation, but let's see how to add a second animation. We need to import the second one, file import, and FBX, Sitting Loathing. So it's a different one. But what it did is it added another armature. We can just get rid of it. Right click and delete hierarchy. Now if we go on the first armature, we go back into dub sheet and we select the new animation. We can play, we know it's this one. The name is incorrect. So it was Sitting Man, I don't remember exactly, and hit push down. Now we have only one armature in our file. If we go into nonlinear animation, we have our two animations inside that single armature. If we go here, animation NLA track, we have two tracks with the good animation name. Once you are good with all your animations, or you can just save it and add other animations later, hit File, Export, and this time we will export it as a GLB. Go to Public, Models, and you can name it animations.glb. The format, it will be GLB. Go to Geometry, hit Compression, and all the default settings should be good. Then hit Export GLTF. Now that you have your animations.glb file, you just need to use GLTF to save it into animations. Then use animations with the animation that you loaded. Do it on the group that is containing your whole avatar. Where is it? Here, the main group. And have the code that is running our animation based on the animation we are currently on. So what I did is a use state on all the animation. If it finds an idle one, it will start with the idle. If not, it will play the first animation available in our file. So it's generic. So now our avatar is ready. It has all the different animation that I added in my file. Automatically, if you're using my code and different avatar file, it will be able to show that drop down in Leva. So you will have access to all animations. Now let's have a look at the facial expression. If you look here, you can see that our character expression change and the values here, based on what morphTarget is affected by it, is updated. When I do it, you can see all the different parameters updated and we have a new facial expression. This one looks sad. This one is surprised. It's me that created them by using the different morphTargets available. I won't go too deep in the explanation of what is a morphTarget because I already explained it in the first video. So let's say we want to create our own facial expression. If we try to move here the morphTarget, it won't work because it's automatically updated based on the facial expression. So to be able to update it, we need to enable setup mode. And then if we go here, now we can start moving the different parameters. So let's say I want to do something very special. I'm doing randomly, so it's not a really accurate facial expression. just fine-tune and do something that you think look good and that you would like to have at your disposal for your chatbot. And once you have everything set up correctly, you can click on Log MorphTarget Values. What you will have is in the console, you can copy all the different values here, copy it to your clipboard, then go on top of the avatar file. You can see we have all those animations. So you can just add a new one, you name it the way you want. So for example, weird face, double dot, we create a new properties and we paste all the one we had. If I save, it will automatically put them correctly thanks to pressure. Now I reload, I go to facial expression and I have my weird face that I just created. And I can just fine tune it later, add other one or enhance the existing ones and replacing the values. I will just get rid of it because it looks very weird. And let's have a look at what it does. So we have surprise, for example, it's the name of the morph target. And the code responsible for that is pretty simple. We have a use frame. We are looking that we are not in setup mode. And we loop through each morph target available on our model. So iLeft is just the container that has all the definition of all the morph targets. So this is the list of morph target they have here. We iterate through each of them. We get the mapping of our current facial expression, and we check in our current facial expression if we have the key defined. For example, if we are on angry, we are currently on jaw forward, we have it, so we will go into the one value. If it's a value we don't have, we will lerp it into 0 instead of the value of the facial expression. You can see that I added two conditions for the eye blink left and the eye blink right, because I created something separately and manually to naturally blink. Just before talking about blink, go to lerp morph target, and what it does, it's going through all our object. If it's a skin mesh and has a morph target, we will update the value of the morph target. And the set here is made to update level, so it's very not important, which results in smooth transition between the different facial expressions. And then for the eyes, you can see we have blink, wink left and wink right, which are states. And we make it separate from the facial expression. We just lerp the morph target based on the value of blink and wink. So that's how our eyes are animated. Let's have a look at how we change blink value. We have a use effect that is setting a timeout with a random value between 1 second and 5 seconds. And it will just run blink. It will set it to true. And after 200 milliseconds, it will set it to false. So at a random interval, it will blink the eyes and it will just last 200 seconds because it is very fast. If we wait a bit, we should see at any time the eyes blinking. We just have seen it. And wink left and wink right are just manual actions set on lever. I didn't use it for the chatbot. Now we have covered almost all the front end. We can remove hidden on the UI and add hidden on lever. I created a simple UI by using Tailwind. On our UI, we have a title here, some action buttons that are really basic, and the chat buttons. But to be able to use the chat, we will need to run our backend. So clone the repository, run yarn to install the dependencies, and yarn dev to run it. It is listening on port 3000. If we go back to the front end, we have a hook named useChat that is responsible to do requests to the chatbot. So you can see it's calling localhost 3000 and it's doing different requests and getting the message. For now, we can just try it. If we click send.
Hey dear, how was your day? I missed you so much. Please, don't go for so long.
It did three things. It's animated our character by changing the animation, changing the facial expression based on the sentence, and also animated the lips. Let's go to the backend and see how it works. Everything is coded easily in index.js. The first thing we need to set up is our environment because we need an OpenAI API key and also an ElevenLabs API key. To install .env, run yarn at .env. Then on the root of your backend, you have to create a file named .env. It is in the git ignore, so you won't have it by default because it contains sensitive data such as your OpenAPI key and your ElevenLabs API key. To create your own API key, you will need to go to platform.openai.com, create an account and add a payment system, and create a new secret key. Then the value you get, you paste it for your OpenAI API key. Then to interact with OpenAI, I'm using the OpenAI node, the official NPM package, to interact with it. So the documentation can help you understand how it works in depth, but let's see together my own implementation of it. What I did is I create a new OpenAI. I'm adding the API key that I guess from the environment. This is because .env.config will automatically load the .env file into process.env. Then we are using Express to create some API routes. We can scroll down. We have a post route named chat that takes a message and replies us with useful information. When we don't send a message, so if we don't have user message, we automatically send a message that isn't coming from ChatGPT or ElevenLabs. It's a message I already recorded, so we are not consuming any ChatGPT data. So this is the format the backend is sending back to the frontend. We have messages. It's an array of messages. Each message contains a text. It's what we send to ElevenLabs to play the audio. Then we have an audio. It's the audio file generated by ElevenLabs to have it played by our frontend. Then we have lip sync, is what we are generating using Rhubarb library. Don't worry for those two. We will explain them just after. And we also have the facial expression that is available in our frontend and the animation. So we have all those information that helps our avatar to play like a human. If we play it again.
Hey dear, how was your day? I missed you so much. Please, don't go for so long.
That's why her animation changes, because on the first message and first audio, she is smiling and just talking. But right after, when she starts the second message, she is sad and crying. But those messages are hard-coded. What we want to do is to use ChatGPT and ElevenLabs to generate them based on our user message. Let's go down. This part is not important for now. We are calling openai.chat.completions.create to do calls to ChatGPT. It takes the model, so GPT 3.5 Turbo is ChatGPT, and it takes an array of messages as an input. The role system are the indication to the bot on how it has to behave. So inside the content, I defined a very important rule that define what I will get as an output from ChatGPT. So you are a virtual girlfriend. It will help the bot to understand how it has to behave. Then I'm asking it to always reply with a JSON array of messages, because I want to be able to JSON parse the output of it to have my messages and to have them accessible in the code with a maximum of 3 messages. It was to avoid to generate too many audios and to have it very slow. Each message has a text, facial expression, and animation property. So this is what we have here: text, facial expression, and animation. ChatGPT will give us those 3 information. The 2 others, we will be generating them ourselves. I'm also explaining to ChatGPT what are the different facial expressions that are available in the frontend. So there are smile, sad, angry, etc. Of course, if you created other facial expression, add them to the list here. It's exactly the same concept for the animations. All the ones that you created with Mixamo and Blender, add them to this list. These are the instructions for the bot. Then in a second message, we need to say what the user typed, and it's the user message that we write inside the input. When we send it, we get the response. Because we said it's a JSON, we can do JSON.parse on it and get it from the content. Then I added a safe check because sometimes it returns me directly an array of messages, and sometimes it's returning me an object containing a messages array. So I have this line of code, but happily it seems to send it in those 2 formats only. Maybe there are alternatives way in the prompt to fix it. So far, let's have a look at what it does. So console.log messages, and we will return. Let's send, can you tell me a funny story? In the backend, we will have the log of it. So this is the response from ChatGPT. We have an array of messages. We have the text, the facial expression. So when it starts, it's smiling and talking. then it does a funny face and talking, then it is laughing. Now we have those messages, we need to generate audio from it. We can remove our console log and go further in our code. We will iterate through all our messages one by one. We'll define a file name and the text input to call ElevenLabs API. We'll see later how to set up properly ElevenLabs, but just have a look at the whole logic for now. We have that method, voice.text-to-speech. What it will do, it will call ElevenLabs API with a voice ID. We'll have a look at it later. The file name, where it will store our audio file, and the text input that it is used to generate that audio file. If I go to audios, I can listen to the last one, for example, message 0.mp3.
Yes, I can dance.
And I have that message. Okay, when I have this, we need to generate the lip sync so the avatar in the front end is able to move its mouth. To do this, I created a method named lipsyncMessage. It's doing two things. The first one is it's converting the MP3 into a WAV file because the library we are using is not compatible with MP3. So you need on your backend to have FFmpeg installed on it. On OS X, it's pretty easy to install it. You just have to do brew install FFmpeg. For Windows, I have no idea now, so you can just Google it and find the solution. Let's go back to it. After we do the conversion, we are running our Rhubarb library. What this binary will do is it will save into an audio message.json file, a JSON output from the audio file that we want. And I use -r phonetic, so it's faster, but it's not the most accurate one. If we look at our files, we have message 0, it is the MP3 we are starting from. Then we are converting it into a WAV file, so it's still an audio file. And from it, when we run Rhubarb, it's generating us a file containing all the mouth information that we will need to render inside our frontend to animate the mouth. To understand how it works, I recommend you to watch the first video. It's where I explain how Rhubarb works and how we animate the mouth of our avatar. When we have executed those commands, we just send it back to our frontend. It has an array of messages. Let's try it in our frontend. Can you dance?
Yes, I can dance.
You can see on the right, we had one message, animation Roomba, the audio information encoded in base 64, the facial expression, all the lip sync informations, and the text. But I'm not using the text in the front end, but we could display it in the front end anywhere. I won't cover the whole code because it's pretty easy to read, but before finishing, let's have a look at how we are calling ElevenLabs API and how you can set up your own. What you will need is your API key. You can create an account on ElevenLabs, go to your profile, click on profile, and copy your API key from here. This is free until 10,000 characters. Even while developing it, I only used 3,000. Then we need a voice ID. It's the voice we want to use to generate the audio file. This is when you go to speech synthesis, the voice you select from this drop-down. You can see I have generated 2 voices for me. Go to Voice Lab and you can create 3 voices of yours, but you can also use the default one that are available here. So inside Voice Lab, you can add generative or clone voice. You have a voice library and you can find a lot of useful voices. That sounds good, but you can also create yours and fine tune it. To find the voice ID, you have to go to api.elevenlabs.io/v1/voices. But the issue here is we are not passing it our auth token. So we have only all the default voices available. Maybe I can zoom. You can see the name and the voice ID. That's why on the backend, once you have set up your ElevenLabs API key, you can go onto /voices and we are getting the voices with our API key. So let's change the URL to localhost 3000. And here we have other voice. If I search for Emma, which is the one I created, it is now available. And I just have to copy the voice ID here. Once you have it, paste it here in voice ID. I know I'm a pig, I could have set it into the environment file. to call ElevenLabs instead of calling directly the API through a REST route, I'm using ElevenLabs node, which is an NPM package with useful methods we can use to go faster. Thank you for watching. I hope you enjoyed this video and you will create great products around these concepts. I haven't covered all the code, but the main interesting concepts that I didn't cover in previous videos. If you had a good time with me, don't hesitate to hit the like button, as it really helps the channel grow and be more visible to other developers. Don't forget to subscribe to not miss the upcoming videos, and in the meantime you can continue your journey by watching my existing videos available here.